Welcome to Study Loop.
Okay, so we need to prove this equation from this. So this is the equation for a parallel plate capacitor where capacitance is epsilon naught. This is a constant times area over the separation. So if we know the area of the parallel plate capacitor and the separation, we can figure out the capacitance. Now, since we know that the potential is same for each capacitor because they are connected in parallel, and also since they're connected in parallel, the total charge on the capacitors will be the sum of the individual charges. So we need to use these concepts to uh, find out this equation. So first of all, let's find out the individual charges on each capacitor. So that's going to be Q1, which is C1 times V, C1 times V, because V is same for all of them. And C1 is going to be epsilon naught times A1, area for the first capacitor, separation for first capacitor, and then voltage. Q2 is going to be C2 times V, which is epsilon naught A2 over D2 times V, and similarly Q3 is going to be C3 times V, which is epsilon naught A3 by D3 over V. Now, since we said that the net charge or the total charge should be equal to the sum of three charges, so we can add them together and we get something. So we'll add these three. So let's add them and let's see what we get. So that plus epsilon naught A2 over D2 plus epsilon naught A3 D3 V. So we see these two guys are common for all three, so we can take them outside. So we'll have A1 D1 mm, plus A2 D2 plus A3 D3. Now from there we know that C net should be Q total divided by the voltage. So if we write the expression of Q total from here, it's going to be epsilon naught A1 D1 epsilon naught A2 D2 plus epsilon naught A3 D3 times V. So we're taking V out divided by V. So we get rid of V from there. And what is this? So if we look at equation 17.7, we see that this is nothing but the capacitor for parallel plate. So we have C1, C2, and C3. C1, C2, and C3. So we saw that we got back the equation 9.5. Thank you.